Hello, class. Hello, STC and dual. That's dual and AP, pre-calculus. We're going to see how this goes. Sometimes you're going to see that I lecture a lot, but it's to be spread out, maybe for more than just one day or one lesson. This particular lesson that we're going to start today, which you already started because you did the introductory video, and it was a very good video. It did get you into at least the foundations of double angle identity. This lesson in our book goes more. It does double angle identity, half angle identities. It goes into sum to products and products to sum. In the middle there, it doesn't. That I won't highlight a lot because, frankly, I've never used it in my life. But double angle and half angle come up off and on in life. And I'm hoping that the introductory video you did and the assignment to check that you did watch it, maybe you're going to be bored because you do already understand a lot of this. Okay, let's start out with what double angle means. If I have two of an angles, whether they're A or whether they're B's or whether they're thetas or whether they're X's, it's the same thing as saying two of the angles being added together. So in essence, we derive the double angle identity from the sum of two angles. Not sum and difference, because that wouldn't be double. So since we're using this, let me see if you had to remember what cosine of a sum was. And that was, as I recall, cosine, change the sign, sine. So that would be cosine A minus sine A, sine A. Oh, right here, I think I wrote cosine minus sine. Slide. Okay, they were doing it. They're going to cosine A minus, it's always the opposite, sine A. That is the identity. But we can simplify that because these two angles are the same, so it's cosine times cosine squared, and minus sine squared. This is the one that I usually memorize. But since you had another identity before, using your Pythagorean identity, so sine squared A plus cosine squared A is 1. Sometimes people will use this and say, well, then sine squared A is really 1 minus cosine squared A. So you could take all of this and substitute, that's cosine squared A minus all of 1 minus cosine squared A. So distributing the negative gives you cosine squared A minus 1 plus another cosine squared A. So that gives you technically 2 cosine squares A minus 1. So even though I like this one, this is the go-to one that I always will write down. Because what it does is it takes the double angle, and A is actually half of that double angle, whatever angle was there. And this is easy to write. And this is also easier to do in my head. Let's say the angle was, try to get something that would make sense. No, all our special angles are already, we have memorized. You could do this with the cosine of 60 degrees as 30 plus 30 and actually do it this way. Not that you would, because if you have 60, you already know with a special triangle. That's 30 up here. That's 1, 2, square root of 3. So we don't need anything special with 60, but It's just kind of interesting. Just to finish this page, if you decided to take this Pythagorean identity and solve it for cosine squared a, that would be 1 minus sine squared a. So you can see where I'm coming from. I'm going to now take all of this and plug it into this. And that's going to give me 1 minus sine squared a minus another sine squared a. And what do we get? 1 minus 2 sine squared a. And I'm not going to lie to you. These two and these two look so close the same that I sometimes get them mixed up. So that's why I don't memorize all three. In my head, I just remember this one. And if I need these two, and I think I see something that looks like these two, then I'll go ahead and I'll do my Pythagorean identity, solve for each of them, and just play around with it. I've told you 1,000 times, I try to memorize as little as possible because I'm trying to, where did I write my notes? When I do, my Teflon brain will forget. There is the same derivation. Cosine here. When I do sine, then if we're going to do the double angle of sine, let's see if we remember. Double angle of sine was, what was that? Let's see, go back to that. It was sine, cosine, keep the sine, cosine, sine, switching the angles. So this would turn into sine of A, cosine of A, keep the sine, cosine of A, sine of A. But A is the same all the way across, so even if these two were switched around, I can move this around to still make the same thing as I have here. So we just leave it as 2 sine A cosine A. And that's pretty much, there's not going to be 3 different kinds for that one, because there's no square term in there. There it is. The more you memorize those, you don't have to derive them every single time. But I will be honest with you. Every calculus student I have, they always forget them. So they're always having to Google it real quick when you need it. To say, what's the double angle of cosine? What's the double angle of sine? And I guess that's why God made Google, to remind us. Now, tangent, if you recall tangent A and B, I think it was tangent of one plus tangent of the other over 1 minus the product of tangent of A, tangent of B. That's what that was. Well, let's plug it into when A is the same. Tangent of one plus tangent of the other, which is the same thing, over 1 minus the product, tangent A, tangent A. And you can see what happens here. These two are identical, so it turns into 2 tangent of A over 1 minus, these are identical, so it's tangent of A squared. So I always go back to just A and B and say, well, what does the A and B's look like? And if I know what A and B looks like, I don't necessarily have to memorize this because I can derive it when I need it. Yes, I have it right. And most books, pre-cal books, calculus books, have the charts where they list all your double angle identities. And obviously Google has them all. Which one do I memorize? I only memorize this one. But if you had them all memorized, then you already had the cosine. You could just use this one if you had it all memorized. But again, I never have this one memorized, so I'm stuck with using cosine squared minus sine squared. So let's use that idea. In example 1, and you may have done this same problem on the YouTube introductory video that I sent you. Please let me know if you like looking at other people's videos more than mine. My feelings won't be hurt, and maybe I don't have to do as much work. But if we know that cosine of a single angle, theta, was 3/5, and we were in, I know on the homework problem, I forgot to tell you what quadrant I was using. I didn't use the same. I told you I use quadrant 1, it's easier, but I think the one on the video, he was in quadrant 4 maybe or something. I don't remember. I did send you a message because somebody so smart in one of the dual classes said, "Sir, don't we need to know what quadrant?" And so they were right. So we're all we know is that sine is less than 0. Well, if sine is less than 0, that tells me that this angle either had to be here or here, because sine is negative in those two quadrants. Let's find the double angle of sine, the double angle of cosine, the double angle of tangent. So if you have the formula memorized by now, we know that sine of 2 theta was 2 sine theta cosine theta. Well, we have already given to us cosine of theta. That's going to go here. But you don't have sine of theta. So you're going to have to take a second. Now, realize, we know it's going to be negative. We know sine of theta is going to be negative something. So I'm going to draw my triangle, my right triangle. Realize that if this is theta, he gave me cosine, which is adjacent, over hypotenuse. It's just a matter of finding out what this piece is, because sine of theta will be opposite over hypotenuse. So I need the opposite. Without doing any work, do you memorize that if one leg is a 3 and the hypotenuse of 5 is a 3, 4, 5? And I'll prove it to you. 5 squared is 25 minus 3 squared, which is 9, is 16. Square root of 16 is 4. So it is a 4. So it is a 4. So here goes. Equals to 2. Sine is 4/5. Don't forget it was negative in that quadrant. And cosine was 3/5. So that gives me a negative 24 over 25. Now we're going to do cosine of 2 theta. And as I told you, there's 3 of them. I'm showing you what I'd be doing. Equals cosine squared theta minus sine squared theta. I already did all the work a minute ago. That was 3/5 squared minus negative 4/5 squared. It is negative, but it's not going to matter because I'm squaring it. 9/25 minus 16/25, and that's a negative 7/25 if I didn't make any mistakes. And of course, if I made a mistake, no one's going to stop me. So there's going to be chances doing this distance learning that I'm going to run through a whole 15 minutes before I find a mistake. I'm not going to edit every video every time I make a mistake. But at least you will always remember that I'm human. Let's see if that answer is right. Sine of 2 theta was, if I'm right, negative 24/25, and cosine was negative 7/25. Said negative 24 and a negative 7/25. Oh, I had it set up here to do it. And what I did was I made a note of my identity that I might need. So that was what I already forgot what I was getting ready to do. And I didn't do the tangent one. I didn't do the tangent one. Let's go ahead. Let's do tangent of 2 theta, which we memorized was 2 tangent of theta over 1 minus tangent squared theta. Now, we had that. That is your formula you could have used. And it works just fine. You could find, we had that triangle. That was a 4, that was a 3, that was a 5. This was theta. I believe that was the one I had because we were given cosine was 3/5, yes. So it isn't unusual to write that formula out and say that tangent of theta will always be 4/3. So it's 2 times 4/3 over 1 minus 4/3 squared. And that's fine. That's 8/3 over 1 minus 16/9. Well, that doesn't look much fun. 1 minus 16/9 is the same as 9/9 minus 16/9. That's a negative 7/9. So that really gives me 8/3 divided by a negative 7/9, which is negative 8/3 times the reciprocal. No, the first one was not negative. Where am I getting that? I told you I'd make a mistake. 8/3 times negative 9 cents. I'm hoping my answer is negative 72/21, but I do think it reduces by a 3, so negative 24/7. Now, I liked what the gentleman did in the video. He didn't use this identity. He just remembered the other identity that tangent of something is always sine of something over cosine of something. We already had our answers on the previous page. Let's do it this way to see if I get the same answer. Sine of theta, well, no, we had sine of theta, but we're not doing that. We're doing tangent of 2 theta, which will be sine of 2 theta over cosine of 2 theta. So I got to go back and look to see what sine of 2 theta was. Negative 24 over negative 7/25. And when you multiply the top fraction by the reciprocal of the bottom, the 25ths cancel out, the negatives cancel out. Negative 24. Oh, wow. I'm impressed with myself. So it worked out. I think I'm right since that. Oh, I said my negatives cancel out. Why did I put a negative here? Doggone it. Came out pretty. Let's see. Here's all their solutions. Let's see if we were right. Negative 7/25. Okay. 24/7. Was that my final answer? That dirty dog. All right. He does talk about Oh, yeah, he did it a different way. That's another way. He just did it in terms of tangent of theta. He did tangent of 2 thetas, tangent of theta. Okay, yeah. Same answer. Example 2. Find all the values of the 6 trigonometric functions if we know that cosine of 2 theta is 4/5. So now he wants me to find all trig functions of theta, not 2 theta. He wants what's the sine of theta, what's the cosine of theta, what's the tangent of theta, and then do all the reciprocals to do the cosecant of theta. Okay, so obviously we're going in reverse. If we're going to use, what quadrant am I in? I'm in between 90 and 180. That's quadrant 2. Keep that in mind because that will make cosine negative, that will make tangent negative, and their reciprocals be negative. All right, you ready? So cosine of 2 theta, I'll use the only one that I memorize. Actually, I think I changed my mind. I think I will use one of the others. I'll use this one. 1 minus sine squared theta. The reason, well, it's not even theta, it is theta, is I want to find the sine of theta. So I already know this answer is 4/5. 1 minus sine squared theta. If I solve this for sine squared theta, I got 4/5 minus 1. That's the same thing. Equals negative sine squared theta. 4/5 minus 5/5 and negative 1/5 equals to a negative sine squared theta. Divide both sides by a negative. 4/5. Oh, that was a negative 1/5, sorry. 1/5, that equals sine squared theta. Take the square root of both sides. Ta-da, you're done. I would say plus or minus, but sine in this quadrant, in quadrant 2, sine's positive. So I only want the positive one. So sine of theta is the square root of 1/5, which is 1 over the square root of 5, which is square root of 5 over 5. That's if I rationalize the denominator. So now that I'm on a roll, to get the cosine of theta, I'll use this identity. Cosine of 2a is 2 cosine squared theta. What am I doing? Theta minus 1. Again, I'll use the same answer. 4/5 equals to 2 cosine squared theta minus 1. That turns into 4/5 plus 1 equals to 2 cosine squared theta. That becomes 9/5 equals to 2 cosine squared theta. Divide both sides by 2. That's 9/10 equals 2 cosine squared theta. Take the square root both sides, which normally I have plus or minus, but since I'm in quadrant 2, right here, quadrant 2, it's going to be a negative answer. Negative 3 over the square root of 10 equals to cosine of theta. Rationalize it. Negative 3 square roots of 10 over 10 equals cosine of theta. Now we're doing the tangent one. He wants a tangent also. Oh yeah, we want all 6. So let's start listing what I have so far. Sine of theta, if I'm correct, is square root of 5 over 5. Cosine of theta, if I'm correct, is negative 3 square roots of 10 over 10. Tangent of theta, I'm not even going to do I'm just going to use that tangent of theta is the sine over the cosine. Square root of 5 over 5 times the reciprocal of the cosine. Negative 10 over 3 square roots of 10. It gives me, the 5 cancels out the 10 with 2, so that gives me a negative 2 square roots of 5 over 3 square roots of 10. Rationalize the denominator, multiply both sides by square root of 10 over square root of 10. That gives me negative 2 square roots of 50 over 3 square root of 100, which obviously that turns that back into a 10. So that's 2 square roots of 25 times square roots of 2 over 3 times 10, which is 30, equals to, that's a 5. Right here is a 5. That's 2. That's 10. 10 square roots of 2 over 30. Square root of 2 over 3. Oh my gosh. Did I lose my negative somewhere? I did. There should be a negative here, negative here, negative here. Negative square root of 2 over 3. So we put that answer up. Tangent of theta is negative square root of 2 over 3. I hope those are all right. If they're not, I hope that you already found the mistakes. And I'm going to have faith in you that you can do it. All right, just turn off the Netflix and turn off the TV and concentrate, and you don't need me. You guys will learn this all on your own. Let's see. Okay, cosecant of theta is the reciprocal of sine. Up here when I did the sine of theta, and before I rationalize the denominator, if I flip this right now, before I do this, it'll be easier to do cosecant. Cosecant of theta would have just been the reciprocal square root of 5 over 1. So that one's done. When I did the cosine, right here, before I rationalize the denominator, if I flip it now, I get a negative square root of 10 over 3. So that would be, that's cosecant. Secant of theta would be, what did I say? Before I flipped it, would be the square root of 3, square root of 10 over 3. And cotangent is the reciprocal of the tangent of theta. So I could go back and look, see, did I have that answer before I rationalized it? I do. It's still ugly. It's still, well, let's put it this way. This could have, before I did this, I could have made this into, well, no, it already, I'm sorry. When I flip this, it's going to be 3, negative 3 over the square root of 2, which has to be rationalized now. That'd be a negative 3 square roots of 2 over 2. Negative 3 square roots of 2 over 2. That's a lot of work. A lot of work. But if you could do that problem, then you understand how to decompose a double angle identity and create the half. So let's see. The same one I just did. Yeah, it is. Okay. I even forgot what the problem was. Maybe I don't want to know. Square root of 10 over 10. I have square root of 5 over 5. What did I not do? I know you're probably yelling at the screen right now saying, you're wrong, you're wrong. Cosine of 2 theta was 4/5, and I'm using the identity 1. Oh, shoot. Why didn't anybody tell me? You would have. There's a 2 here. 2. I bet you any money I did it wrong on the other one too, cosine. No, that one I actually have it. Wow. So that explains I'm missing 2 here. Let's see. I can fix it really quick. Supposed to be a 2 here. Supposed to be a 2 here. Supposed to be a minus 2 here. That gives me a negative 1 over 10. Or 1 over 10. And then that gives me a 10. And that gives me the square root of 10 over 10. So that's fixed. I'm only human. Let's see. It looks like I did this formula. I put the 2 here. So I must be okay. Let's check it out. Negative 3 square root of 10 over 10. Tangent. I don't have that. Let me make sure I put the right formula down. Oh, I didn't do it his way, I don't think. I'm definitely going to do it. I already had my sine and cosine. Oh, this won't be right because I had the wrong sign. Remember? So that's why. But we were in quadrant 2. And we already did all our we had our sine. We fixed our sine. Our sine of theta is, well, this was 2 theta. So, interesting thing, when he said that we were in quadrant 2, this double angle was in quadrant 2. If you think about it, if you take half of that angle, you'll no longer be in quadrant 2. The 1 theta is going to be in this angle. That's kind of interesting. Which explains why all our answers, I think, are coming out positive. Because you're no longer in quadrant 2, you're in quadrant 1. When you take half that angle, it doesn't go as far. You only go half the distance. Let's see. Okay, I have it all set up. Is that the same problem? 4/5. Which of those would be better? I could probably use any of them, but he wants it in terms of, what was the problem? He wants them all in sine of x's? I'd probably use this one. Cosine of 2x is 1 minus 2 sine squared. Those answers look right. Let's see. Sine of theta squared root of 10 over 10. Did I have that? All right, let's move on here. Not there. Negative 3 squared, so 10 over 10, got it. And then have a tangent answer. Oh, he said negative 1/3. We found that mistake. So obviously, if we take the two answers that we had and do the sine over cosine, you'll get the negative 1/3. And say which one of those would tangent to the. Okay, simplify expressions using double angle. Okay, so we have this. This should stand out as, oh, cosine squared minus sine. That's a double angle of cosine. So what you could do is just say, well then that theta has to be half. This is actually half of the original 2 theta. Because if cosine of 2 theta is cosine squared theta minus sine squared theta, which, by the way, I left this up here for you, this angle is double these angles. So we know that we have to double. So I think that answer is really already there. If you simplify it, what's 2 times 7? Should be just a 14x. So cosine of 14x. Now this is sine, cosine. Remember what sine of 2x is? It's 2 sine x cosine x. But he only has a 1 here. So he divided this by a 2. That's why you got the 1/2 of, and this angle here. Anyway, this together is double angle. This is the theta, so I need to double that. So we should see a 30 degrees in there. I'm not sure what he was talking about. All his notes here. All my identities real fast. There's the double. There's the double. So 1/2 sine of 30 degrees. Now, he went further. It did say simplify. You need to remember that that was equal to a half. Right triangle. Theta. 1, 2, square root of 3. 1/2. So 1/2 times 1/2 is 1/4. If I go back and just look. Write sine of 3x in terms of a sine of x. So he wants me to write only sine of x's. I got you started here. I broke 3x's into 2x's plus x. That's going to be a double angle in a second. So if you use your identity, this is equal to 2 sine of the first, 2x. We're actually using the angle sum. Angle sum. Sine, wait, I better do this right. Sine of 2x. It's sine cosine of x. Keep the sine cosine of 2x. Sine of x. Now we have our double angle. That's a double angle. That's a double angle. Double angle of sine of 2x would be 2 sine of x cosine x, bring this one down, cosine x plus cosine of 2x is going to be, you got to decide which identity you want to use. 1 minus 2 sine squared x times the sine of x. All right, so that turns into, it gets kind of harder because they only want sines. Everything has to be turned into sines. So this multiplies together, get a cosine squared. So 2 sine x cosine squared x, which is not a sine, but we'll get there, plus this one is going to have to be distributed, plus the sine of x, I like that, minus, well, that I don't like, 2 sine cubed x. Now this can use that identity, that sine squared x plus cosine squared x is 1. That means cosine squared x equals 1 minus sine squared x. So that's 2 sine of x times 1 minus sine squared x's. This one here is going to be plus sine of x and minus 2 sine cubed x. Well, I don't know what else he was doing. If I distribute everything in there, that gives me 2 sine of x times 1 is 2 sine of x. 2 sine of x times a negative sine squared is 2 sine cubed x plus sine of x minus 2 sine cubed x. Two sine of x plus sine of x is 3 sine of x minus 2 minus 4 sine to the fourth. No, minus 4 sine cubed x. Well, I don't have any, all I have is sine x's in there. So I hope that's it. Take a look. There it is. A lot of work. All right. Let's pause there. He's got an application. And we're looking at a graph. And we're going to move into product sums. So why don't we pause this here. I'll put a math lab assignment just based on sum, double angle of sum, double angle of sines, double angle of cosines, double angle of tangents. And we'll just pause this here and I'll post a new one probably tomorrow. Have a good day, guys. I should say I'd rather be there teaching you. It's kind of hard lecturing. And the only thing that's looking at me are my cats. Take care and be safe.